Good morning and welcome to the E-class of St.Xaviers High School, Adipur. Today we are going to study Science of Standard 8, chapter number 4, that is Metals and Non-Metals, part 2. So in part 1 we have studied about the physical properties of metals and non-metals as well as the uses of the metals and non-metals. Now let us see the chemical properties of the metals and non-metals. When the reaction is occurring with the oxygen. When metal is reacting with the oxygen, what will happen? Suppose the iron is taken. Okay, so what will happen when it will come direct contact with the air, that is oxygen, then it will get rusted. That iron will get rusted, and then we come to know that the oxygen has been reacted with this metal. That's why we are using the oil paints for covering of the iron surface. Let us see one more example. React oxygen of copper. A copper vessel is exposed to the moist air for long. It acquires a dull green coating. Suppose this is a vessel, then the outer covering of the vessel, what will happen? A dull green coating will occur when it will come in the direct contact with the water or the moisture. Okay, the green material is a mixture of copper hydroxide and copper carbonate. So here is the copper hydroxide CuOH twice, copper carbonate CuCO3. Now let us see the reaction, that there are two molecules of copper. Okay, two molecules of copper when reacted with one molecule of the water, one molecule of the carbon dioxide, one molecule of the oxygen, then what it will give? It will give copper hydroxide and copper carbonate CuOH twice, CuCO3. Now let us see the best example which we have learned in our 7th standard, that the magnesium ribbon. If we burn this magnesium ribbon, the ash obtained on burning magnesium ribbon is dissolved in water and tested acidic or basic or neutral. Okay, so how we will come to know? We will use the litmus paper and we will dip into the solution, and when it will get, the red will get turned into the blue. That means the water solution, the solution is basic. But whereas if there is no change in color and the litmus paper remains red in color itself, then it means that the solution is acidic in nature. Let us see, one question will arise in our mind, that is the solution acidic or basic? How do you ascertain this? You must have observed that the red litmus paper turns blue. So oxide of magnesium is also basic in nature. In general, metallic oxides are basic in nature. So from here we can come to know that the metallic oxide of magnesium is also basic. So from here the metal oxides are basic in nature. Okay, in general it is stated that. Whereas the non-metallic oxides are acidic in nature. Let us see how. When the reaction of non-metals with oxygen occur, suppose we have taken sulfur. Okay, it is a non-metal. Okay, sulfur when reacted with the oxygen, it will give sulfur dioxide, that is SO2. Then this SO2 is dissolved in water. Okay, then in water, what is the formula of the water? That is H2O. Okay, H2O when reacted with the SO2, that is the sulfur dioxide, it will give H2SO3. Okay, H2SO3 is the sulfurous oxide and H2SO4 is the sulfuric oxide acid, sulfuric acid, and sulfurous acid is H2SO3. Let us see the reaction, how it is formed. Well, the S plus O2 will give what? SO2. Now this SO2 when reacted with, when entered into the water, then it will give sulfurous acid, and this sulfurous acid turns blue litmus paper into red. Okay, generally the oxides of non-metals are acidic in nature. Okay, so these are the non-metals which are react with oxygen, and then we can come to know that they are acidic in nature. So reaction with water. Till now we have seen the reaction with oxygen and then with the water, but now here it will come in direct contact with the water. Sodium metal is very reactive. It reacts vigorously, okay, with oxygen and water. A lot of heat is generated in the reaction. It is therefore stored in kerosene. So sodium metal है, that is Na. उसका symbol is, okay, that is Na. So that sodium when entered with the reacted with the oxygen or the water, then it will be very vigorous reaction. बहुत instant and बहुत fast reaction होता है. Okay. Then when sodium reacts with vigorously with water, okay, some other metals do not do so. Okay, sodium is an exception. For example, iron. Iron reacts with water slowly. It reacts but very slowly. But here the sodium metals reacts very fast. Generally, non-metals do not react with water, though they may be very reactive in air. Okay, so non-metals are reactive in air. वो जब ऑक्सीजन के साथ डिसॉल्व होते हैं, then it can be reactive with the water. But solo, that is, we have learned about C. Here we have seen the sulfur. Okay, it is a non-metal. Sulfur is a non-metal. Okay, and when reacted with oxygen, then it is reactive. Otherwise, non-metals are non-reactive with the water. Okay, only the oxides of the non-metals react with water. So non-metals are stored in water. So the non-metals can be stored in water. For example, phosphorus is a very reactive non-metal. It can catch fire if exposed to the air. To prevent the contact of phosphorus with atmospheric oxygen, then it is stored in water. This phosphorus is stored in water for the betterment, so that it doesn't catch the fire when it comes in contact with the air. Now let us see reactions with acids. Non-metal generally do not react with acids, but metal reacts with acids and produce hydrogen gas that burns with a pop-up sound. Okay, a tuck करके pop-up sound आएगा when it reacts with acid. Who? Metals. You must have noticed that the copper does not react with dilute hydrochloric acid. Dilute hydrochloric acid के साथ क्यों react नहीं करेगा? Because it is not in the pure form. That's why it will not react with the dilute. Dilute means जिसमें बहुत ज़्यादा amount of water हो. Okay, the more amount of water. It is not in the pure form. Even on heating, but it reacts with the sulfuric acid, because the sulfuric acid is very reactive, and with the sulfuric acid, the metal can react, and a pop-up sound will come, and the gas, that is hydrogen gas, will be liberated. The pop-up sound indicates the presence of the hydrogen gas. Metals react with sodium hydroxide to produce hydrogen gas. Our last topic, that is displacement reaction. Here let us see that there are 5 beakers, and in this 5 beakers we are having different kinds of solution, and in different kinds of solution we are having different kind of metal inserted in it. Here you can see the A and B. A and B's colors are same. Why the color are same? Because the solution is also same, that is of the copper sulfate. Copper sulfate is a colored blue. Okay, due to the copper, the blue color comes in this solution. Here the zinc sulfate is there, here iron sulfate is there, and here the zinc sulfate solution is there. And this iron sulfate solution is of, you can see, yellowish color. Why? Because iron gives this color to this solution. Okay. Now let us see how this displacement reaction has been occurred. In copper sulfate solution, in one beaker we have zinc granule, and in another beaker we are having iron nail. See, here it is written everything. In the copper sulfate, zinc granule, and in the beaker B with the copper sulfate we are having iron nail. In the beaker C, zinc sulfate plus copper turnings, iron sulfate, copper turnings, zinc sulfate plus iron nail. So now let us see what happened and why here the reaction has been occurred, and the changes are, in some beakers we can see changes, and in some beakers we can't see the changes. Let us see. Here you can see the A has been converted. Okay. Why? Because this copper sulfate, in that zinc plates are there, zinc granules are there. What will happen? This zinc granule is, zinc is very reactive. Zinc is very reactive as comparatively to the copper sulfate, which is the solution given in the beaker. This copper sulfate, okay, will leave the sulfate, and this sulfate will be reacting with the zinc sulfate, and this will form the zinc sulfate solution. That's why the color has been changed into red. In the beaker B, copper sulfate plus iron is added. Here you can see the change in color. So iron has changed the solution color. Copper has to leave the sulfate, and here the iron sulfate is formed because iron is more reactive than the copper. So by this we can come to know that the zinc and iron are reactive, okay, than the copper. Now let us see beaker C. In this, zinc sulfate solution is there plus copper turnings are there, but there is no reaction. So by this also we can come to know that zinc is more reactive than the copper. Now let us see in the D beaker, iron sulfate plus copper tunings are there, but there is no change in color. So by this also we can come to know that zinc is more reactive than iron. And iron is more reactive than copper. Let us see the E, in which zinc sulfate plus iron is there. Okay, the two reactive metals, but let us see who is more reactive. See, there is a zinc sulfate solution, and in that iron nail is there, but there is no change. So we can come to know that zinc is more reactive than iron as well as copper. Now, iron is more reactive than copper, and copper is less reactive than these two. Now let us take one example, our daily example. Okay? The person, suppose the person is which is very strong. Okay? To them other people will come, or that strong people will go to other people? No. Strong people will be firm, and the person which are not strong, then that person will continue to join the strong person. Okay. In the same way, this displacement reaction occur. The more reactive matter, then the displacement reaction will not occur. If there is less reactive matter, then the more reactive metal can displace the less reactive metal. Okay. Metal displaces another metal from its compound in aqueous solution. We have studied till now. In a beaker A, zinc replaces copper from copper sulfate. That is why the blue color of the copper sulfate disappears, and a powdery red mass of copper is deposited on the bottom of the beaker. The reaction can be represented as follows. Copper sulfate, when reacted with the zinc, that is blue color, then what will happen? Zinc sulfate colorless, copper will be having red color. Copper का color क्या था? Blue. Okay, and then it converted into red due to the zinc. Okay. Now there are definite rules based on the facts. Zinc is more reactive than copper and iron. A more reactive metal can replace a less reactive metal, but a less reactive metal cannot be replaced by cannot replace the more reactive metal. So your home assignment is to write the question and answers in your science notebook and write objectives in your science textbook. Thank you and have a nice day.